Morris here from the Smart Energy Lab. This time it's a little box, but it's a little box with a big heart. This is an AERL maximum power point tracker. Yeah, but it's got something that not many others have. It's a 120 volt DC battery configurable. This is designed for up to 600 volts PV arrays. So, wow, that's pretty cool. So why is it kind of special? Well, AERL, now let me go back a little bit. There are three great inventions that Australia's famous for. The stump jump plough, Wi-Fi, and the maximum power point tracking charge controller. Yep, that's an Australian invention. Stuart Watkinson, back in 1983, a young engineer, made the first one. The company's been around ever since then, and I've owned some of them. I think I've got one of the early ones up on the wall here. Oh, wait a minute. This was my first AERL. Check it out. In the days when no one had a maximum power point tracking charge controller, AERL made these. Now, these were like handmade by Stuart Watkinson. The manual was hilarious. I think he wanted to economize on paper, so it was sort of like the letters were all jammed together, but it worked, and it meant that you could have longer strings of panels. You didn't have to have your pulse width modulated charge controller's limit of sort of a 12-volt battery with a 12-volt panel. So we've come a long way since this little baby. Let's get into the newest Coolmax. So this is the Coolmax 120 volt battery, 600 volt MPPT, 600 volt input. Wow. I mean, once upon a time, MPPTs were 150 volts max. Even this one. But AERL have taken it to the next level, to 600 volts. Now, why is that a big deal? Well, anyone who's done grid connect systems will know that it's much, much easier to string panels together into high voltage strings than have lots of paralleling. So you can wire this like a conventional string inverter, but it's a charge controller for a battery. Here's the installation manual. It's come a long way since the originator, Stuart Watkinson, wrote this one. He wrote, the original manual from Stuart Watkinson. I think his son Peter has done a much more modern job of a user manual. Now, let's get into the box. It's all cardboard packaging. I like that. There's no polystyrene to get rid of. It's all recyclable. Now, if I just get it out. Well, here we go. I guess this is the thumbnail shot, right? Got to have one of those. But anyway, this beautiful looking piece of equipment actually can take up to 6, I think it is, let me just double check. Yep, 6 kilowatts of PV. Now, a 6 kilowatt inverter is much bigger than this. This thing weighs, I don't know, it's a few kilos. It can take 6 kilowatts of PV. It'll convert up to 4.5 kilowatts continuous charge into a battery at a 120 volt battery system. It'll have the ability to DC couple to that battery. Now, if you're not familiar with DC coupling means, if you have a solar inverter, its output is AC, and you might have a separate battery inverter who's bidirectional that can charge a battery. But the connection between the two is through an AC bus. What that means is you've got to have two inverters for a start, a battery inverter and a solar inverter, and you've got to have an AC network, and you've got to have both of them working for it to charge that battery. With a DC coupled system, like using an MPPT, it doesn't need an inverter to charge the battery. So it's a separate function. You could say it's a dedicated function to charge batteries. The battery can have an inverter connected to it, of course, but it's not the primary way of charging that battery. The primary way would be through this MPPT. Now, there's another special feature of this charge controller. In fact, very, very few have this feature. I can only think of one other on the Australian market. It has earth fault detection. It's been a requirement in our PV array standard, AS/NZS 5033, to have earth fault detection on PV arrays over 120 volts, and for our battery standard, AS/NZS 5139, for batteries over 60 volts. So this has earth fault detection. Now, that's a big deal because otherwise you wouldn't be installing this legally without that earth fault detection. You could have bought an external device to do the earth fault detection, but it would cost nearly as much as an MPPT. So yeah, this is a much better solution. Now let's have a look at the business end here. There's not a lot to see on an MPPT. We've got battery in, solar in, and we've got our comms. So the little display on the front here tells you a little bit about what's going on the unit. And if I turn it onto its side, I can read some of its specs. So open circuit voltage maximum 600 volts, nominal voltage 336 volts. That means at its maximum efficiency. Its maximum PV input current is 12 amps. That's the IMP. And its maximum short circuit current is 18 amps. Now let's just do that little calculation that I love to do, which is what's the largest short circuit current rating of the PV array that can be connected to this unit. So we allow for a 1.25 times safety margin on our PV standard for the short circuit current rating of the module, or in the case of a string of them, of the array, with respect to all of the downstream devices and equipment. So cables, connectors, charge controllers, inputs to the charge controller. So the reciprocal of 1.25 is 0.8. So if I get my magical calculator out here and put in the short circuit current rating, which is 18 amps, and I multiply it by 0.8, it tells me that the maximum short circuit current rating of the PV array that I would connect to this is 14.4 amps. And that's basically your resi panels. Most of them are less than 14.4. So this is ideal for your residential panel sizes with modest short circuit current ratings. The other numbers on the side here is the MPPT range. So from 215 to 540 volts, and the nominal battery of 120, and a maximum battery charge current of 30 amps. So that's how we get our 4.5 kilowatts of charge into the battery, is the battery voltage times 30 amps. The operating temperature range minus 20 to positive 50, and protection class 1. So there you go. The AERL CoolMax 120 volt battery, 600 volt input charge controller. I'm excited. We're going to be installing this on a system here in the lab very shortly. Probably another video on that. Anyway, thanks for watching. Check it.